We're going to start our very first notes for the Unit 1, which is Say It With Symbols. So I want to start by just reading the statement of inquiry because that drives our whole unit, and really that's going to lay the foundation of why we're starting with some of the stuff we're starting. So our statement of inquiry for this Unit 1 is, we solve mathematical puzzles using simplification, equivalence, and logic while justifying the result. So today, since this is our very first time taking notes in algebra this year, we are only going to complete the vocabulary section, which means we're going to come back to this exact same note sheet tomorrow. Now, like I said in the Canvas module, if you don't like to take notes on your iPad, like maybe Notability isn't your favorite thing in the world, you can absolutely be using a separate sheet of paper, right, like a notebook, and you're just going to write down the important stuff. As in, you're going to write down 1.1 at the top, and maybe you'd write the word notes. And then we're going to start with the vocabulary. So since we're really talking about solving these mathematical puzzles, we kind of need to have some vocabulary in order to be able to talk about these things. So the first thing that I want to talk about today, which also shows up in that statement of inquiry, equivalence, is the phrase equivalent expressions. Equivalent expressions. So an equivalent expression is really just math statements that say the same thing, or I would define it as math statements that are equal. And when you think about it, hopefully that kind of makes sense, because when I think about the word equivalent and equal, they do sound kind of the same, right? They've got that same root word, equal, equivalent. The reason why I put equal in quotation marks is technically we're not going to be saying things are equal when we're looking at two equivalent expressions, but quite honestly, it is really what it means. They mean the same thing. Now, the next vocabulary word we have to define is really just a word to make sure that we all know what we're talking about, because we're going to use this a lot this school year. A coefficient is simply a number in front of a variable. And if you forgot what a variable is, I want to remind you that those would be like the letters in our math. So like the X, the Y, the N, the Q, whatever. So if I was going to give just like a little example of what I mean when I say the number in front of a variable, if I have the expression 2x plus 4y, we would say that both the 2 and the 4 are coefficients. So 2 and 4 are coefficients. Next, the building blocks of what an expression even is would be the terms. So I always describe these as a piece of an expression and the way you can tell what a term is it's really, they're separated by the plus and minus signs. So I'm going to add that. Separated by the plus or the minus signs. So when I look at that example that I wrote for coefficient, the 2x plus the 4y, we know that the 2 and the 4 are coefficients. When I say the piece of an expression where separated by plus or minus signs, I see one little plus sign in the middle, which means this must separate these two pieces or these two chunks, these two parts. So this would be a term, and this would be a term. The 2x and the 4y. Last but certainly not least, let's define what like terms are. So we already know what a term is, right? A term would be a piece of an expression. So like terms are going to be terms with the same variable. Terms with the same variable. And again, variable just means the letter, right? Those letter things that represent numbers, but we just don't know what that number is. So I can't really reference the example above because 2x and 4y, those have different letters, right? I don't have any like terms in that expression. So let me write a brand new expression that we can look at. So if, for example, I have 5a minus 6c plus 4c. So first things first, I'm going to identify my terms. They're always separated by the plus or minus signs, right? So I see a minus sign here and a plus sign here, which means those two things, they're like almost like you can kind of picture it like these are the walls essentially, right? So I see a 5a, I see a 6c, I see a 4c. Now the one really important thing to understand is that math reads from left to right just like English. So when I read this, I see a 5a, and then I'm seeing a minus sign, so I know that there must be the start of a new term, so that's got to be a term. I see a 6c and then a plus sign, so I know that this must be a new term. But saying that it is a minus 6c, that minus sign gets attached to the 6. So technically we would say that this coefficient is a negative 6 or a minus 6. Now when I keep reading, I see a plus 4c, so again, I include the plus or the minus signs to say the part of the term, but in this case, like a plus 4c, plus just means positive, so we would just say that this is a 4c. So in this example then, we have two like terms. We've got the negative 6c and the 4c. I know that they are like terms because both of them have the variable c. 5a does not have another like term in this expression. It's got nothing that matches with it, so we only have one pair of like terms. So make sure your vocabulary section is complete, and we will complete the rest of these notes tomorrow. Nice work today, 8th graders.